Yo, what's up, man? It's your boy again here, man. Listen here, man. So let's get started, man. So we have the first question right there. So we have to integrate. So with this, we have to integrate the following. So integrate the following. So the first integral, say integral sign or power 4x. That's not 4x, power 4x, right? The second one, integral power 6 3x. Cos integral of cos 12 24 mdm. So in all the other integrals, so we have to integrate all of this. Let's get started with the first question, right? So before we get started for integral, right, you have to know this trigonometric identity, right? So I'm gonna write again the trig identity. Let me write here, right? So it's right there. See, the right there, but I'm gonna write again so everybody can see. So the trig identity, you have to know whenever you have a cos of double angle, this same is a cos square. You see, this is a double, so you divide by 2, and they say your angle means whichever angle you have divided by 2 is x, and they say minus that angle divided by 2, you get what? Also sine. You say sine square of this is a double, so means when you split it, it's gonna be x, means 2x divided by x is x. So before you solve this equation, right, you have to know that, okay? So excuse me. So if somebody give me, let's say, cos 2 theta, mean this gonna be equal to cos 2, means cos double angle theta, means double theta, mean this is gonna be theta minus sine square theta. So you're gonna have to know that before we solve this equation, right? So excuse me. So now I can split that one further, right? Saying I'm gonna say this same and say, look, in the non-identity you have to know whenever you have a cos square of angle plus sine square of angle always equal to 1. Equal to 1. You see what I'm saying? So cos square angle plus sine square angle equal to 1. So now look here. If I want my double angle has to be cos everything. Look. So let's say I don't want this sine. We're gonna start to solve the equation right now, right? But I want you to get used. You have to be familiar with this face. See? So if let's say I want my cos double angle has to be sine. Okay, so I'm gonna have to eliminate this. So it's okay. So what is cos meaning? Cos meaning equal to 1 minus, I'll take this one over minus what? Sine square of angle. So if I had to eliminate cos square, meaning is 1 minus sine square. So this is gonna become, instead of say cos square, I'll say 1 minus sine square. It's gonna be 1 minus sine square of angle, and here we have sine square of angle. So then what happened? So what happened is, look, negative and negative is going to be negative 2. So this let me say 1 minus 2 means negative 1 sine, negative 1 sine means negative 2 sine square of angle. So sometime the same cos double my angle is same as, excuse me, double my angle is same as say 1 minus 2 sine square my angle. So you see the same double angle, but you could write them as a sine means 1 minus sine square. Or so this and this is the same thing. Oh, I don't want to have sine. I want to have everything. I have to have a cos. I'm going to use the origin double angle here. So I'm going to say cos double angle. Now I don't want to have a sine here. So what is sine? Look here. In a trig identity, what is trig identity? Cos square of angle minus plus sine square of angle equal to 1. So I don't want this sine. What does that mean in this identity? So if I don't want a sine, means if sine square of angle equal to 1 minus cos square of my angle. So instead of sine square, if I don't want this sine square, I'm gonna say okay, 1 minus cos square. So this is gonna become, look there, man. So this is gonna become is we have a cos square of angle minus what is sine square? Sine square means 1 minus cos square. So it's 1 minus cos square of angle. So this is gonna become, so we have a cos square of angle minus, multiply that out, go minus 1 minus plus cos square of angle plus cos, we're gonna get what? 2 cos square of angle minus 1. So cos double angle. Oh, okay. So the same cos double angle, I could write them in 3 different ways. Man, you guys, look, man. The same cos double angle, it could be 2 cos square minus 1 or 1 minus 2 sine square or cos square minus sine square. So first and foremost, before we start to solve this equation, you have to know that. See what I'm saying? So from now, so everybody of course they know this, man. I mean, cos double angle means cos double angle equal to cos of x minus sine. Means like if this is double, when you divide by 2 you get x and x. That's this. And here we know the double angle, of course. Or I could have written like this or like this, and this is normal identity. Sine square plus cos square equal to 1. So let's solve the first question, man. So let's see how we can use this trig identity solve trigonometric integral. Let's check the first integral, the integral, and then we have a sine for x dx. So first of all, man, you see, whenever you have a power here, make sure you change it so they go to the double angle, right? So the tricky, like whenever you have a power, change it to normal double angle. It doesn't have a power. So look here. So I don't have a power 4, so I want to say okay. So let me take this as how. Okay, so sine, I came into here, excuse me. I'll say sine power 4 x, meaning sine x square. Why do 2 square? Because look, in double angle, so which I'm going to use? If I say this is sine, of course I'm going to use the middle one because it has a sine. Look here, sine square. So if you have any power here, look, power 4, I want to say square. Why? Because I have a square, so I'm going to use this, of course, and then I'll say square. So this and this is the same thing, so it didn't change any meaning. So sine square x. So this and this is the same thing. Why do they? I know this one. I can get it from here. So I'm going to say okay, but from the double angle, look here. If I want to get sine square, means I can make this sine square subject. So from the double angle, okay. So we know from the double angle we have a cos. If I take this one over to the left and then take this to the right, so what happened? If you take that to the left, it's going to be cos, excuse me. If you take this, okay, take this to the left, so it's going to be positive. So it's going to be 2 sine square x. And I'm going to take, so on the right hand side, on the left with 1. And they'll take this list to the right. So if this is positive, when it goes to the right, it's going to be minus cos by the double angle. You see what I'm saying? But I want to make what? Sine square x subject. So divide by 2 and then divide by 2 over. So this and this cancel. So sine square of x meaning 1 minus cos double angle over 2. You see? So what happened? Now I'm going to replace this with this one. So if I have a sine, because this is sine square, so sine square meaning 1 minus cos double angle over 2. So when you say sine power 4x, meaning bracket 1 minus, I'm going to replace this one with 1 minus cos square. So cos double my angle over 2, but I have my square. So what happened? I'm going to take this and plug it in here because sine double power 4 equal to that one right there. Okay, easy. So then, so let me call this tie equation. Let's just call this tie equation. So I'm going to say sub into tie equation. Means you're going to substitute this into tie equation. So it's going to become, so we're going to have integral, and this is going to be 1 minus cos double my angle over 2, and then I have my square dx. Okay. So what that mean? This meaning, right? This meaning, so we're going to do normal square, right? We can do normal square. Okay. So now we're going to say, if, okay, so this let me say integral, this is going to be 4, because if you square, separate, let's not bother about the numerator. So this is like a 2x square over 4. This is going to be 4, because 2 square is going to be 4, so 4 dx. I can take this to the back, so it's going to be 1 over 4 integral 1 minus cos 2x square dx. So this is what I have to deal with right now. Okay, it's gonna be look, 1 minus cos 2x. When you square this, let me say 1, okay, excuse me, 1 cos 2x times 1 cos 2x. So let's start to multiply now, right? So 1 times 1, 1. 1 times negative 2x, negative 2 cos 2x. Now we go for the second one. Negative cos, okay. 1 times 1 is 1, and then 1 times negative cos 2x, negative cos 2x. Negative cos 2x times 1 is negative cos 2x. Negative cos 2x times negative cos 2x is going to be cos positive 2x. So this is what we're going to have. And these two are negative. It's going to be 1 minus 2 cos 2x plus cos 2x. Normal factorization. So we're going to take this and plug it here. So we're going to say 1 over 4 and integral. Okay, so we're going to say 1 minus 2 cos 2x plus cos square 2x dx. So we're going to raise this out of here. Shows me, let's make it space quick. Y'all, the question's almost finished, man. And we can separate this integral. Saying this time I say 1 over 4 is outside, and this is going to be integral separately for 1 dx, because we can separate, it's acceptable. And then you go minus 2 is constant, and they have integral cos 2x dx. And then we have plus integral for the last one, integral cos square 2x dx. And the question is almost finished, but the only problem is here. So we're going to have to apply the same tricky we did, because whenever you see the square, power 4 power 6, you have to apply the trig identity. So we're going to have to break in trig identity, the same methodology that we did for how we started. So this is going to be okay, this is going to be okay, but only here because it has a square. So you have to use the same tricky. So okay, so now let's go this equation 1. This is going to be fine, this is going to be fine, but only here. It doesn't have a power, it doesn't have a power, but this has a power. So we have to do the same strategy. So look here, man. I think this space is enough here. So this is what we're going to do. I'm going to say, so we want to break this into double angle. So look, it's square but it's cos. So of course I'm going to use this. It's square but it's cos. So of course I'm going to use this because this is a double angle but it has a square. So I'm going to say, okay, look. So this is similar to this. So what that means I have to tag this. Look. So it's cos 2x equal, exactly right. So 2 cos square x minus 1. But for this case, look, this is this. But it's double, this is 2. So here must be what? It must be 2. Excuse me. This must be 2 here. And if this 2, this must be 4 then. For that case, if this 2, this must be 4. Because when it chose x from the formula, this was 2x. So if this is, but for this, in the question, it's not x, it's 2x here in the square. So if this is 2, means of course this must be 4. It's not 2. So this must be 4. Okay. And what happened? I'm going to have to make this subject cos square x because, yeah. So this, I'll take this one over. So it's going to be cos for x plus 1 equal to 2 cos square 2x. And then divide by 2 and then divide by 2. This and this cancels. So cos square 2x meaning cos for x plus 1 over 2. So now I'm going to take this and plug it in here in the integral. So I'm going to raise this part. I hope you saw. So I'm going to raise, right? Okay. So we know how it came. So I'm going to, we need to make a space here. So let me try to raise the equations. But I do remember, I'm going to write them again. So don't worry about it. Say, man, why did you raise those questions? So I'm going to raise, but I do have them in a piece of paper. So we're going to redo them, all of them. So we're going to leave the question that we have to solve. So I'm going to say this one here is going to become, this part here is going to be fine. So let's continue. So we're going to say, okay, so now the question is going to become, so 1 over 4 is just 1 over 4. Or equal to 1 over 4. And then we're going to put bigger bracket. When you integrate dx, you're going to get x. And when you integrate here, this is going to be 2. Excuse me, 2. You just say 2. But when you integrate this, look here. So it's like integral cos of 2x. Like integral cos of 2x dx. But whenever you integrate function, you say 1 over, you derivate this. You say d dx of whatever you have there. But it's 2x. And then when you integrate sine, when you integrate cos is sine. sine of the same, whichever we have there. Do you understand what I'm saying? And then when you differentiate 2x, it's going to give you your 2. So finally, this equal to 1 over 2 sine of 2x. You know what I'm saying? That's how you get it. So now when you integrate this part here, we're going to get 1 over 2 sine of 2x. You know what I'm saying? So I'm going to write this. We know 1 over 2 sine of 2x, but we have a negative 2 which is there. So we're going to say bracket. You know what I'm saying? And then we're going to say 1 over 2 sine of 2x. Sine of 2x. Sine of 2x here is okay. So now we go for the last one. The one which was giving us a problem. So we know it's cos 4x plus 1 is this one. So we're going to say integral. So minus, no, it's plus, excuse me. And then we say integral. So cos square, we don't need square when you integrate, like I said, right? So meaning this equal to cos 4x plus 1. So this is cos 4x plus 1 over 2. Over 2. And then we have a dx. So we have a dx. Okay, so, excuse me, we don't need this, so just erase here. Because we got the value plugged in. Okay, so now we say, excuse me. So now we say, let's finish. Easy. So now we're gonna say, okay, so this is let me say 1 over 4. So now let's break this, right? Let's take this aside and try to integrate. That's all. Okay, so I'm gonna say but. Let me take this aside here. So we're gonna say but. So and then we're gonna substitute. So we say but. So this integral of cos 4x plus 1, I can take 2 out. Like 2 out, so it's going to be 1 over 2. So it's going to be 1 over 2 integral of cos 4x plus 1 dx. Because 2 is constant, so it can go out of the integral. It's constant, it can take out of the integral. Yes! So now we say this is, let me say 1 over 2. And then integral of cos 4x dx plus integral of 1 of the second one, because for the first one and the second one, dx. Okay, and this is going to give us 1 over 2. So now look, we have a cos again. Cos, so look, when you integrate cos, you're going to say 1 over, and then you differentiate whatever is here. I mean that function which is in front of the cos. So when you differentiate 4x, you're going to get 4. So just say 4, and then when you integrate cos, you get sine. So sine, and then write exactly 4x. And they say plus, when you integrate dx, you get x. Okay, so this is this. So when you integrate cos 4x plus 1 over 2 dx, you get this. So I'll take this one here, but we can simplify further. So this is going to be 1 over 80 sine 4x, and then plug it in. This is going to be a half x. So when you integrate this, you get this. So I'll take this and plug it in there in that equation. So finally, we're going to have, so we finalize the equation. So now we say, when you integrate, finally, means sine 4x dx, we're going to get 1 over 4. We got x, and the minus. These two and two cancel. So it's like sine 2x, and that one is going to be plus. We're going to plug in this here. This is this, and this is that one. So this is this one, 1 over 8. So it's like 1 over 8. See? Sine 4x plus a half x. But a plus c. Final plus or plus constant. So now we say we can put it in. Let's put it in. So it's going to be 1 over 4. 1 over 4. So we can plug it in 1 over 4. X minus 1 over 4 times that one is 1 over 4 sine 2x. 1 over 4 times that one is going to be 1 over 32 sine of 4x, and 1 over 4 times 1 over 2 is 1 over 8, but an x, because 1 over 4 times 1 over 2x plus c. Yo man, so look here man, so 1 over 4x plus, this is a plus here man, I think I forgot it, this is 1 over 2, when you plus it's going to be, there's a plus here, I forgot, there's a plus here, plus, so plus 1 over 8, so look here, plus, so this 1 over 8x plus 1 over 4x, so this is going to give a 3, see, 3 over 8x, 3 over 8x, because this and this is going to be 3 over 8 minus 1 over 4 sine 2x plus 1 over 32 sine of 4x plus c. So man, and that's how you solve the question. If you have a question, man, let me know, man. It's your boy Game, man. I'm trying to battle Academy, man. Hamish, man. You know, share with a lot of people as much as I can. You know, share with a lot of women. You know, this is for our sister. We do this because for mom, well, grandmom, our sister. So, you know, if you have any women out there struggle with mathematics, try to share with her, man. You know, if you have a sister, mom, grandma, share with them. Thanks a lot, man. I appreciate it, man. Yes! So if you have any question, man, anytime, you know, leave the comments. If this video was very helpful, leave the comments. You know, try to share with other people. You have any question anytime, let me know. Let me know. Yes!